Happy Monday, Algebra 2 class. So today we're going to continue with factoring trinomials where a doesn't equal 1 anymore, but the trinomial has a greatest common factor. So I'm going to refer back to our note sheet here. And if you remember, the first thing we always do is look for a greatest common factor. All right. If you have a greatest common factor, you always want to start there. That's the first thing you're going to do. And then we can look and see if we can use one of these other methods. So that's what we're going to work on today, is using greatest common factor along with what we did last time, factoring a trinomial. So let's look at this second example here. 2w squared plus 20w plus 50. So I see that 2 goes into all of these. So that's the first thing I'm going to do, is take out a greatest common factor. So we get w squared plus 10w plus 25. All right. So even though I took out the greatest common factor, that doesn't mean that I'm done, because the directions are always going to be factor completely. So I want to look at what's left in the parentheses here and think, can I factor that anymore? Well, we have to think about, are there any two numbers that multiply to 25 and add to 10? Well, I can have 1 and 25 or 5 and 5. Well, hey, 5 and 5 add to 10. So my final answer, the 2 stays out front because it's still part of my answer, and then I have w plus 5 and w plus 5. Or you might remember that we can write this in a shorthand, w plus 5, because we have 2 of them, it's squared. All right? So you're looking for a greatest common factor first, and then doing exactly what we did last class. Let's do a couple more examples here just to get the idea. So the next example, we have 3p squared plus 33p plus 30. Well, right off the bat, I see a GCF of 3. And then I'm left with p squared plus 11p plus 10. So now we think, what multiplies to 10 that adds to 11? 1 and 10, 2 and 5. Looks like 1 and 10 is the solution. So 3 stays out front, and then my answer, my fully factored answer, is p plus 1 and p plus 10 after that. Okay, making sure that all the factors always go in parentheses. 3 doesn't have to go in parentheses because it's in front of the parenthesis and it's only one term. All right, one more. -2, 10, -12. Well, if the front term is negative, I always want to take out a lead negative number. So I'm going to take out -2. And then left, I have n squared minus 5n plus 6. So I'm dividing all these pieces by -2. And then now I have to figure out what multiplies to 6 that could add to -5. Oops, I did that backwards. Well, we have 1 and 6, or -1 and -6. We have 2 and 3, or -2 and -3. That gives me 7, -7, 5, and -5. So that is the correct one. So keeping the -2 in front, my factors now become n minus 2 and n minus 3 from the values we found down here. All right. So go ahead and give this